Good morning, myself HAYAT. Now, today I will discuss the topic that is the laws of thermodynamics, the basic introduction of the thermodynamics. So, what is thermodynamics? Basically, the thermodynamics, it gives the following question. First of all, for any reaction defined by a set of reactants and products set in exactly defined condition such as temperature, pressure, concentration, will that reaction go forward spontaneously or not? It can address any geochemical reaction. If there say no rest, assure the reaction will not proceed. If thermo says yes, then we can progress to the next question, how fast? So basically, the term thermodynamics makes by the two words. One is the thermo and another one is the dynamics. So dynamics means motion and thermo means heat. So when the heat are in the motion, then the thermodynamics plays the role. So basically it is the interaction of heat and energy. Basically, when we say that the definition of the thermodynamics, so it is the branch of science which deals with energy level and the transfer of energy between system and between state of matter. So basically, the term thermodynamics behave the property of the pressure, volume, temperature of a gas, either steam, so that any matter which has certain quantity of pressure, heat and its temperature, so it deals that how the motion of the phenomena that goes into a velocity. What is energy? Energy क्या है? Basically, the term energy, it is important to realize that in physics today we have no knowledge of what energy is. We do not have a picture that energy comes in little blocks of a definite amount. It is now that way. It is the statement by the Richard Feynman. Basically, every substance there are some energy must be there. A body is to be exist into the nature because there are some internal energy must be placed. So how the energy occurs? Basically, every molecules, either system, there are small molecules in between this. According to the microscopic and macroscopic approach, that while we applying the force on a subjected body, then the one particles may force to the another adjacent particles and it going to be in the motion. So energy plays a very important role in the thermodynamics. So this one is the energy which is in the form of kinetic energy, potential energy, internal energy. So there are the various type of the energy that exist in the nature. However, Feynman goes on to elaborate that energy has meaning as a way to define and quantify change which bring about changes between system, energy level or state of matter for any reaction. The transformation of the energy, we know that according to the law of conservation of energy, that one form of the energy that is converted directly into the another form of the energy. So according to the Feynman, that one energy that transfer to the another form of the energy. How seriously must we take the physical existence of the energy? No more and no less than any other bookkeeping practicals according to the Rich Feynman. Basically, the physical existence of any body that is depend upon that how much energy is stored in a body. That there are the states. The different type refers to the energy content of a given system. The state is defined by specific certain variables such as temperature, pressure, volume and composition state. Variable is specifically refer to the change inherent if the reaction proceed because of a change in state. Variables are either extensive or intrinsic. The two main important function is the what is the state. State refers to the energy content of a given system. What state the energy is to be moves from one place to another place, and what is the temperature and pressure. There are two terms, one is the extensive, another one is the intrinsic. Variables which are proportional to the quantity of the matter, such as volume, that energy is known as extensive, and intrinsic variables which are independent of quantity, that instead describe the whole system, such as density, temperature and concentration. So it depends upon density, temperature and concentration. This is intrinsic, and extensive, that is totally depend upon the quantity of matter, such as volume. Now becomes that the system, already in the previous video we discussed about the various type of the system, such as open system, closed system, isolated system. So basically the term indicates that it reflect by the mass and energy. So the system, universe is the under the consideration, because every substance which exist in the nature, that must exist into a system. That one is the open system, another one is the closed system, then the isolated system. When matter can cross the boundary, then this is called as the open system. So the open system is the system in which the energy and mass both are transferred from the system. In the closed system, when matter cannot cross the boundary, isolated system, boundary seals matter and heat from exchange with another system. So here we discuss that basically the various terms according to the system, open system, closed system and isolated system. Now, picking a system. How the system is to be picked? The investigator picks the system. It can be as large as or small as you want to it. The proper definition of the system is important to address the reaction you want. Leaving out gases or sediments or melts or other can make a problem simpler, tractable or more inaccurate. The defining a system. What is system? A system at equilibrium has a measurable properties. If the system changes from one equilibrium state to another, these changes depend on the properties changes and not on the path the change went along. In thermodynamics, the reactions are not different. Example, catalyst does not affect thermodynamics calculation. Okay, please pause. Process. The way a system change states that the various processes in the thermodynamics, such as isothermal process, isobaric process, isochoric process, adiabatic process, polytropic process. In the adiabatic process, that no heat exchange across the boundary, and in the isobaric process, it at constant pressure, but the boundaries of the system can change, volume changes. So, in the various type of the thermodynamics processes, we have to know that the 5 different processes: isobaric process, isochoric process, thermodynamics process into the concern of adiabatic process, polytropic process, and as well as the isothermal process. The equilibrium and the reversibility. Anything at equilibrium is theoretically undergoing forward and reverse reaction. A plus B, that matters to C, and that C matters to A plus B. A body is to be said to be in equilibrium when it fulfills that after it reactions to A plus B, C, and it's vice versa, that the two criteria B indicates that reaction does not appreciably change in time, perturbation of that equilibrium will result in a return to the equilibrium. Metastable and equilibrium state. Basically, the state of equilibrium, that the lowest possible energy level, so it is called as the stable equilibrium. In the metastable equilibrium, system satisfies above two criteria but is not at lowest possible energy. So this is the figure. In the figure, that you can say that in the metastable equilibrium, when it goes on to the peak, that is the unstable condition, and again it follows into the downward direction, then it is unstable, and then again it goes into the stable equilibrium. So that when it is in the stable equilibrium condition, it has the minimum energy contains, and when it is the metastable equilibrium, then the two criteria, one is the maximum energy and another one is the minimum energy. This one is the historical perspective. According to the Benjamin Thompson in 1798 proposed a link between work and heat generated from observing the boring of the cannons in the Carnot. In 1824, first proposed the concept of the reversibility, and according to the James Joule in 1840 to 1849 measured rising temperature from mechanical, quantifying the relation between work and heat. So basically, when the heat is to be given to a particular system, so there must be some changes occurs into the system. Heat. The origin of the thermodynamics deal with heat. Thermo considers heat and relay any energy as stuff it were an indivisible fluids away flowing from higher to level energies. Ergo signs are positive when energy flow from surrounding to system, and when negative, energy flows from the surrounding. The starting of the thermodynamics that deals with the heat. So the total energy that is depend upon to the how the heat is to be moves on. Work, it is the another kind of energy different from heat. Work is the another kind of energy different from heat, can flow in and out of a system and invoke changes. Imagine the energy required to lift a book. That works changes the potential energy of the book, but it is not related to heat. Work is only be when we do the effort from put a body or system from one place to another place. Internal energy, its symbol is capital U. It may be written as simple U, du or del U. The positive of energy of the system increases. Energy here as heat added positive, work done on the system that is positive, work done by the system that is in the negative. So for the internal energy, when reading other sources, this sign changes, confusion propagates through the reset of the thermodynamics. So one case is very clear that it may be considered that when one is the work done on the system, so it may be positive, and work done by the system, so it may be negative. The mechanical work description, work is equal to integration 0 to x f dx. We know that work, definition of the work, that the force into distance. Whatever the body is placed from one side to the another side, suppose that x distance traveled by the movement of the body from one side to the another side. So the W is equal to 0 to x f dx, because we know that f is equal to p into a, that W is equal to p dv. We put the value of f, p is equal to f by a, f is equal to p into a, dx. That is the limit from one position to the another position x to x naught. So this work is equal to minus p dv. That describes a position movement and the potential energy. Next is the first law of the thermodynamics. According to the first law of the thermodynamics, that the two laws for the first law of the thermodynamics, one is for the based upon the internal energy and another is for based upon the law of conservation. According to the law of conservation, energy not be created, not be destroyed, but one form of the energy that be converted into the another form. When the net change in energy is equal to the heat that flows across a boundary minus the work done by the system, where Q is the heat and W is the work. So according to the first law of the thermodynamics, del U is equal to del Q plus del W. So here Q is heat and W is work. Some heat flowing into a system is converted to work and therefore does not augment the internal energy. Energy change with volume and heat, taking du is equal to dq minus p dv. So from state 1 to state 2, we can write that 1 to 2 integration of internal energy is equal to the 1 to 2 dq minus p integration of 1 to 2 dv. That adds that internal energy u2 minus u1, because we know that q is equal to u plus w, u change of internal energy u2 minus u1, that q q2 minus q1 and p p2 minus p1. That here, when suppose that the Q is a measurable by measuring the temperature changes resulting from energy changes. Another word is the enthalpy, H. Enthalpy is the part of the energy. We can write the formula of enthalpy, that is equal to H is equal to U plus Pv. In this, the enthalpy can be written by capital symbol H, that is equal to U plus Pv. The total differential for the enthalpy is differentiate dH is equal to du plus p dv plus v dp. For our integrated change in state previous, h1 is equal to from u1 minus p1 un from state 1, from state 2 h2 is equal to u2 minus p2 v2. So this is the enthalpy. Recall that energy is not known, only the change is meaningful. Therefore, changes is measured from a reference state, pure elements 25 degrees C, 1 bar pressure have an enthalpy of 0. Second law of the thermodynamics. According to the second law of the thermodynamics, yesterday video we discussed about the Clausius statement and Kelvin-Planck statement, but for the reversible and irreversibility, the second law of the thermodynamics that plays that ds is equal to change of entropy, that value is equal to dq by t. It is an irreversible process. So when entropy ds is greater than dq by t, sum of the enthalpy in a system is not convertible into work because it is consumed by an increase in entropy, which could be resetted that it requires some amount of work to increase the entropy. So second law of the thermodynamics, that the entropy, basically the entropy is the degree of disorderness, that it measurable, that the more the entropy, the more the disorderness. So a system whose entropy is more, that the system doesn't, whose molecules moves in a very large amount. Need for the second law. The first law of the thermodynamics tells that during any process, energy must be conserved. However, the first law tells us nothing about in which direction a process which will be proceed spontaneously. It is a very important point that the first law that doesn't tell which direction the process will go runs. So, for a knows the direction, it would not contradict the first law if a book suddenly jumped off the table and maintained itself at some height above the table. Suppose that अगर हमें किसी बुक को ऊपर से नीचे की ओर गिरा रहे हैं और जिस प्लेस पे गिराना है तो ये ज़रूरी नहीं है कि वो उसी प्लेस पे है, बिकॉज इट डायरेक्शन में भी चेंजेस. It would not contradict the first law if all the oxygen molecules in the air in this random suddenly entered a gas cylinder and stayed there while the valve was open. The second line of words, however, experience tells us that certain processes only runs spontaneously in one direction or the other. This allows us to deduce the second law. So, for the irreversible process, entropy is equal or greater than dq by t. The two formulas for the second law of thermodynamics, one is the Kelvin formulation and another one is the Clausius formulation. It is impossible to construct an engine that working in a cycle shall produce no effect other than the extraction of heat from a reservoir at the production of work. From the classes statement, it is impossible to construct an engine that working in a cycle shall produce no effect other than the transfer of heat from a colder body to the hotter body. So the two rules for classes statement as well as the Kelvin-Planck statement. Kelvin-Planck statement indicates that the transformation of the heat from higher body to the lower body that comes into the Clausius, but in the Kelvin that not 100% conversion of heat into work, some part of the work must goes into the heat, must goes into the environment. Directionally, from the second law, for a spontaneous irreversible process, entropy is always increasing. ds is greater than dq by t. So this is the second law of thermodynamics, basically based upon the Kelvin-Planck statement and Clausius statement as well as the entropy. The meaning of entropy and the second law. Entropy is a measure of the disorder or randomness, according we discussed into the previous, of a system. The higher the entropy of the system, the more the disorderness. The second law states that the universe always becomes more disordered in any real process. The entropy of a system can decrease, but in order for this to happen, the entropy of the surrounding must increase to a greater extent so that the total entropy of the universe always increase. Entropy codes. There is a great difference between energy and available energy. The availability of the energy is always decreasing. This is what is called entropy law, which says that entropy is always increasing. The two part, one is the energy, one is the available energy. Available energy is the energy which transfer to total conversion into the work. So the availability is always into the decreasing order. What is called the entropy? According to the entropy law, that when the entropy decrease, then the energy will be increased. It is a total vice versa, because we know that when something into the increasing order, then appropriate or proportional, that this body is going to be more. But into the case of entropy, when the entropy will be increased, the available energy will be decreased. The thermodynamic sense of order decrease is inherent in the second law is at first sight to conflict with many of the complicated things that we see going on around us. We see complexity and other increasing with time in many situations. When we tidy up our office, the evaluation of complex life from other the simple ones. In many of these cases, we must be careful to pay attention to all the orders and disorder that is present in the problem. Thus, the process of tidying the office requires physical effort on someone's part. The cause order biochemical energy stored in stretches and sugars to be degraded into heat. If one count this into the entropy budget, that the decrease in entropy or disorder associated with the tidy desk is more than compensated for by the other increasing. As such, into the words frame that when we are in the office, that there are some form of the work that we release our heat, release our energy, so that when the energy is to be released from a subjective body, then its entropy will be decreased. Combination, the first law of the second law of the thermodynamics, when we discuss the laws of relations, that dq is equal to dq reversible plus dw, dq may be right here is tds and w is equal to pdv, work done by the system, that it is into the sign of negative. If a process is at constant volume and entropy, nothing happens, energy does not change in the system. du is greater than 0, spontaneous reaction products to reactants, and when du is lesser than 0, spontaneous reactants to the product. So internal energy is 0, the spontaneous reaction produced, internal energy is greater and internal energy is lesser. The temperature, generally when we change of Kelvin to the centigrade, that 273 must be added. The fundamental equations From the first law and the second law, we discussed that Q is equal to U plus W, W is equal to PTV. Then from this, we simulate ds is equal to dq by d, dq is equal to tds. We put these value and simulate that this equation into the form of du is equal to tds minus pdv. This is a key step, but the next one is a constant tone of most thermodynamic calculation. Okay, so here we discuss basically upon the thermodynamics aspects, the introduction, how the different terms of systems, path, surrounding, and the types of the thermodynamics law, first law and second law. So here we only the introduction point of view, the thermodynamics basically govern of the basic approaches that it totally depend upon the heat, work and internal energy. Okay, thank you.